Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-5 lesson on rational equations. In this one, we're going to learn how to solve rational equations, and as a real-life application, we're going to determine how long it takes a group of students to complete a homework assignment if they work together, given their individual rates of work. We're going to depart with tradition and talk about homework at the beginning of the lesson rather than the end here. Let's say it usually takes you 2 hours to finish your math teacher's homework. Oh my, look at all that homework, the humanity. And it takes your buddy 3 hours. Fill out the chart below here, and then write an equation that tells us how long it would take the two of you working together. We'll actually do the first row together, and then I'll let you do the next one on your own. So for person, we've got 2 people, you and your buddy. We're talking about you right now. Fraction of the job done in 1 hour. If it takes you 2 hours to finish the whole thing, assuming you're working at a constant pace, we would say you have done 1/2 of it in 1 hour. Number of hours that you're working with your buddy? Well, we actually don't know. We're trying to figure out how long it would take you working together. So we'll call that X or T, whatever you want. And the part of the job you've completed after 1 hour, well, that's just going to be how much you do per hour times the number of hours. Well, that would just be X over 2. All right. Pause the video, take a sec to see if you can do the next one here. Let's see what you got. So here's your buddy. Fraction of done in 1 hour, 3 hours to do the whole thing, so 1/3 of it is done in 1 hour. Working together with you for the same number of hours that you're working with him. And then part of job completed would be X over 3. Now, the parts of the job completed should add up to the entire job if you throw them together. So we can say X plus 2, the part of the homework that you did, plus X over 3, the part of the job your buddy did, should equal 1 whole finished homework assignment. So now that we've set up this lovely equation, how do we solve it? Since we're adding these two rational expressions together, you might be thinking, well, we need the LCD. And you're right, we do. The LCD in this case being the smallest thing that 2 and 3 go into, namely 6. Only we're not going to try and combine these two things together. We could, that's one way to solve this, but instead a much more efficient approach is to multiply the whole equation, namely the numerators, by the LCD. So I'm going to multiply this fraction by 6, this fraction, and also this constant over here. Now I can go through and cancel out those denominators. 6 over 2 gives us 3. 6 over 3 gives us 2. So we've got 3x plus 2x equals 6. And now this is a very straightforward equation to solve. That combines to 5x. Dividing by 5, we get x equals 6 over 5, or 1.2 hours. That's how long it would take the two of you working together. Now, before we go on our merry way and accept this answer, notice the instructions said solve the equation and check for extraneous roots. Extraneous roots are answers that look good when you go through the process of solving something, but don't actually work when you plug them back in. And the main source of extraneous roots with fractions, sometimes when you plug things back in, it'll make your fraction undefined. So that's really the main thing we're checking for here. And you can see if you plug 6 over 5 back in for x, you're not going to get 0 in any of the denominators. So this works. Our next two examples are going to be a little bit trickier. You'll notice on these already there's a major difference. We have variables in the denominator, so already we're running the risk that we'll be able to plug some numbers in that make these undefined. But we're actually going to start in pretty much the same fashion, finding the LCD. Now there's a little extra step we need to do to find the LCD here. We don't know what all the factors are that we're going to need in the LCD until we factor out this expression here. So two things that multiply to 6 and add up to -5, that would be coincidentally -2 and -3. Won't always be the same, but hopefully it is to make these a little bit easier. So now our LCD, remember, has everything we need to cancel out all the denominators. So if we look at these fractions, we've got an x minus 2, an x minus 3. Those both need to be in our LCD. And looking over here, there's nothing new over here that we didn't already see before. So our LCD then is going to be x minus 2, x minus 3. All right, just like before, we're going to multiply this by all the numerators. So This x here gets an x minus 2x minus 3 next to it. So does this 5, so does this other 5. And here, this is where I'm glad I can just click and make things appear, because that's an awful lot of writing. I know. Some of you might be tempted to try to shortcut the process and not write this out, but I think if you do enough of these, you'll realize that it's very helpful to do this so that you can keep track of things. So now let's cancel out what we can. X minus 2's go away in that first fraction. And that leaves us with x times x minus 3. I'm going to go ahead and distribute that out now. That's x squared minus 3x. Over here, the x minus 3's cancel. Distributing this out, that's going to be plus 5x minus 10. And here, this is the nicest one of all. Everything cancels out that's in a parentheses. So that just leaves us with the lonely number 5. Don't forget your equal sign. All right, let's go ahead and solve this equation now. Combining like terms, we'll have x squared plus 2x, and then if we move this 5 over, that'll be minus 15. All that equals 0. Factoring now, two things that multiply to negative 15 add up to 2. That would be positive 5 and negative 3. And if we set those equal to 0 and solve, we've got x equals 3 and x equals negative 5. Now don't forget to go back and check for extraneous roots. Again, we're looking to see if either of these answers makes our denominator 0 in the original. 3, if you plug it in here, 3 minus 3 is going to give us 0 in this fraction, and it'll also 0 out this other fraction here. So 3 is definitely a problem. That makes the original undefined. So we actually have to cross off 3, and we cannot use it as an answer. Negative 5, on the other hand, if you plug it in here, here, or either of these places, that's not going to cause any troubles. So we can accept x equals negative 5, and that's our final answer. We're going to work through one more example. Pause the video now, and let's see how far you can get with this one. It's sort of similar to the last one. All right, so to start this off, we're going to factor out this denominator to see what kind of factors we have. That'll be x minus 8 and x plus 4, just like the other two denominators. Our LCD then is going to be x minus 8, x plus 4. That has everything we need to cancel out each of the denominators. This is a very useful way of thinking about the LCD in these problems especially, because we know that's just what we're going to be doing, is canceling out those denominators. Multiplying all our numerators by this big LCD now. Take a sec to write all that out, I guess. First fraction, everything cancels except for the negative 3, so that's awfully nice. Next fraction, we've got the x minus 8's canceling. Distributing that 2, that'll be 2x plus 8, and we have an equals there. Over here, the x minus the x plus 4's cancel. Distributing the 3, we've got 3x minus 24. Collecting things now, we've got 5x minus 16 on the right side. We can move this 5x over here to give us negative 8x. Dividing is going to be x equals 2. And just double checking, we'll notice that if we try plugging that back in, it doesn't give us any problems in any of the denominators. We don't get 0 anywhere. So that's a good final answer. So that's it for this one. Till next time, this is Mr. Sutton signing off. Keep it rational.